Hello everyone. In this video lecture session, let's have an overview about electromagnetic energy. First of all, electromagnetic energy. The electromagnetic waves, it's happening throughout this electromagnetic energy, how the electromagnetic spectrum and how about the energy it's getting generated and what are all the process happening in our day-to-day life applications. Let's have a look about this electromagnetic energy in its features as well as the spectrum and the wavelet formation in detail. First of all, before going for the electromagnetic energy in detail, let's have a energy point of view overview. Like ability to do work is energy, but we are already considered the heat energy as a major source, but we have to consider the two major source. One is external as another one is internal. What is the purpose of considering two sources? Because the first source, external source, that is the energy provided by the sun, which has come naturally in our surroundings. But the internal sources, the decay of radioactive substances and the compression inside the earth. So these two sources we have to consider in a primary point of view. That is the purpose. Before going for our electromagnetic energy, first purpose is we have to consider the two sources. So once again, I want to mention that the external source, that is energy provided by the sun, and the internal source, the decay of radioactive substances and the compression inside the earth. Here comes the typical electromagnetic energy definition and how about its working in our surrounding. First of all, what is electromagnetic energy? A type of energy that is given off in the form of transverse waves. So first of all, wave formation from all the matters, but at the same time it not absolute zero. This is what we have to keep in mind carefully about whenever we are doing analytical overview about this electromagnetic energy, the type of energy that is given off in the form of transverse waves. So the energy formation, the energy generation which is happening in the form of transverse waves from all matters not at absolute zero. This is point number one. Why? What is the purpose? Why we are considering this much? Because look at the second line. The transverse waves vibrate at 90-degree angles to the direction. So angle formation. So generally we should not say only typical energy which is forming, generating from all the matters. At the same time, technically speaking, vibrate at 90-degree angles to the direction in which they are moving. So visible light is the type of electromagnetic energy that we are most familiar with it. So electromagnetic energy consideration, we are talking about angles, we are talking about visible light, but overall speaking, the type of energy that is given off in the form of transverse waves from all the matters at the same time, not absolute zero. This is the pictorial representation of the electromagnetic spectrum. What are all this electromagnetic spectrum? Starting from our radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. So this waves, what is the interlinkaged pattern with our day-to-day life surroundings? Starting from our mobile phone, starting from our TV, radio, everywhere the modulation, frequency modulation, FM, everything, this electromagnetic spectrum gets interconnected. So that is the purpose, the commercial purpose, this visible light spectrum plays a vital role. Depending upon these waves, we are getting the spectrum, the light, the ultraviolet waves, X-rays, gammas, depending upon different wavelength. By considering this wavelength, we are considering the overall energy which is happening in the electromagnetic energy. Here comes the meteorological flow chart. What is happening inside the electromagnetic spectrum as shown in the figure previous slide. First of all, X-rays, microwaves. So two categorization. So in this X-rays and microwaves, the gamma rays, ultraviolet, infrared and radio waves. So all are interlinkaged, but in the X-rays point of view, gamma rays look at the arrow mark decreasing wavelength in the left direction and the increasing wavelength in the right direction. So what it's indicating, so microwaves in the category point of view, infrared as well as radio waves, the wavelength it keeps on increasing. So wavelength parameter, if you are considering, we have to refer the decreasing point as well as increasing decreasing point, which is the minimum, which is the maximum. So accordingly, look at the visible light categorization: violet, blue, green, yellow, orange, red. So these are all basic visible light characteristics. So considering this electromagnetic spectrum, what are all the categories? X-rays as well as microwaves. So behind that, gamma rays, ultraviolet, this is one category, and another thing is infrared, radio waves, this is another one. So we have to consider two things. One is increasing wavelength and another one is decreasing wavelength. So depending upon minimum to maximum, accordingly the colors also change, visible light also happens. At the same time, we can categorize the energy generated from the electromagnetic spectrum. So this is the mechanism happening, this is the process which is occurring in this electromagnetic spectrum. Here comes the wavelength, the distance from one crest to the next crest, or the distance between two corresponding points. So here comes the basic technical point of view. This is the base purpose. How about the wavelength getting increasing or decreasing? In the previous slide, just I have mentioned that we have to consider from minimum to maximum, increasing wavelength, decreasing wavelength. But the distance from one crest to the next crest, that is the major important parameter. So we have to consider the distance from one crest to next crest, or the distance between two corresponding points. So two things we have to keep in mind: whether it is attaining the maximum point of view, whether it is attaining the minimum point of view, whether it is a crest or trough. So look at the figure, the crest at the ridge point of view. At the same time, trough, it is the lower bottom point of view. So amplitude, we have to consider the wavelength, so we have to consider the distance. So distance between the 2 points we are considering in the electromagnetic spectrum wavelength formation as well as the generation of energy. Here comes the electromagnetic waves and what are all our dealings. That means human, mankind, or living beings, whatever. That's what the title was given as, electromagnetic waves and us. That means day-to-day life, keep in touch, contact with each other. Not only human beings, it's a living beings, it's a common thing. Because starting from animals, plants, everywhere, starting from the solar energy, this ray of light, natural light, everything is interconnected. So that is the major purpose. Visible light is the only part of the electromagnetic spectrum that can be seen by humans. Look at the figure, the pictorial representation. For example, human, instead of human, they are given as an animal. That elephant we are mentioning. So infrared is often felt due to the heating effects also, because heat energy is also observed with the help of this infrared energy. At the same time, ultraviolet waves causes skin to tan, because depending upon various effects, our skins also get affected due to this waves. So there will be some recommendations, some considerations. We should not receive so much of waves. That means there is some limits point of view. So let me forget about that limit. Only we have to focus. How about the ranges? Being a field oriented point of view, we have to think about the visible light is the only part of the electromagnetic spectrum. So depending upon the visible light, we have to consider how the energy is getting generated. So that's all the overview about this electromagnetic spectrum, how the energy is getting released. That's also already mentioned in our flowchart diagram also. So this is the practical applications and how we are determining this electromagnetic waves. Here comes the interaction between electromagnetic energy and an environment. First thing is, electromagnetic waves can interact with the material. For example, first thing is refraction. Bending in the wave causes a changing in direction, at the same time varying the density. So first interaction, what is the interaction between electromagnetic energy and the environment? As I already mentioned in a previous slide, that what is the difference or what is the interaction between humans and the environment, animals and the electromagnetic energy. But the major point of view is, bending in the wave causes a change in direction. That means in the refraction point of view, look at the figure, the pencil, whether it is bending or the wave is happening or causing by various density, that we have to interact because of the purpose of the material. So that's what they are mentioning, electromagnetic energy and the environment. What are all the particles we are interacting, whether it is a pencil or object or stone or whatever, how it is bending in the wave causing a change in direction. So accordingly, refraction takes place in this electromagnetic waves. Here comes the same point of view but a different aspect. Here it is reflection aspect. So bouncing off the material, at the same time bouncing off the mountainous level. Look at the figure, two things. One is reflection, both are reflection only, but in letters it is automatically same like mirror reflection, bouncing off the material. Common example, we can take it as a mirror. If you are throwing some light in your mirror, it will bounce back. So that is reflection. The same point of view, even in natural beings, look at the water, the mountainous picture is automatically reflecting. So bouncing off the material. So nothing but just an example point of view about the reflection. Why we are mentioning this reflection and refraction? Because electromagnetic energy is also taking place in the form of the spectral point of view. Here comes, okay, spectral point of view is already we have discussed, reflection point of view. Another one more thing is scattered or refracted, whether it is scattering purpose is happening or reflection purpose is happening, whether it is going in same direction or various direction. That point also we have to consider. So transmission to the material, absorption or taken into the material. Look at that, incident energy, it is getting in, the transmitted energy, it's getting down to the ground. For example, just we have observed that sun is liberating energy to the ground, so we are feeling heat. The ground gets discharged the heat energy. At the same time, look at the blue arrow mark, one is reflected energy. Look at the green portion, that is absorbed energy. So the incident energy which is absorbed naturally, it is getting absorbed. At the same time, oppositely, which is transmission through the material, it is getting reflected back. At the same time, absorption also happening, transmission also happening, reflection also happening. So this is what we have to consider, the two criteria. One is reflection, another one is refraction. So one is getting attracted, that is getting absorbed, another one is reflected back. So two variations we have to keep in mind for considering this electromagnetic variations. Here comes the energy absorption. Let me discuss this point in a very highlight manner, like dark colored rough surface absorbs more sunlight than light colored shiny surfaces. One more common example I like to share you, in summer timings or any other things, we people used to say don't put dark colors or something because of the sun heat over, because dark colored rough surface, because these are all common truths. What is the mechanism behind that? The energy absorption is happening. Dark objects are better at radiating heat energy than the lighter objects. So if two nearly identical cups of hot water were left outside at night, darker one cool faster. This is our common scientific principle. What is the mechanism behind? The energy absorption mechanism is behind. So that is the purpose they are mentioning. Dark objects are better at radiating heat energy than the lighter objects. Here comes the pictorial representation of the detailed point of view in this electromagnetic spectrum, starting from the wavelength, starting from 10 power 3 to 1, and then it is going for the -1, -2, it keeps on going. Look at the second category, size of the wavelength, whether it is longer or shorter. Just before a few slides we have discussed about increasing the wavelength, decreasing the wavelength. Same thing here they are mentioning in detail. Look at the waves, radio waves, microwaves, infrared, ultraviolet, hard x-rays, everything, the real practical application day-to-day life, starting from the mobile phone towers. Look at that, FM radios, radio waves, radar, everything, GPS, frequencies, energy for one photon. This is what our surrounding is capturing, this electromagnetic spectrum. Here comes the texture. The rougher the surface, the more energy it will absorb, less it will reflect. So common point of view in the scientific principle, rougher the surface, more energy it will absorb. At the same time, less it will reflect. So mirrors are smooth, so they are shiny. At the same time, they will reflect most of the incoming visible light. As I said previously also, if you are maintaining or if you are flashing any torch or something, any laser light, it will reflect it back, bouncing off. So it depends upon texture also. Texture also plays a vital role. So rougher the surface, more energy it will absorb. At the same time, less it will reflect. Here comes the contact with the land and water. Land warms up and cools down faster than the water, because land, the absorption capacity is more, as we already discussed in the incident energy, how the absorption, obviously reflected also happen, but warms up and cools down faster than the water. So good absorbers of energy are good radius of energy. That means faster something heats up, faster it cools down. Here comes, why is it cold at the poles? Snow and ice reflects much of the insulation back into space. The sun is always low in the sky, so sunlight is less concentrated. The sunlight has to travel through more of the atmosphere because it is low in the sky. So that is the reason why it is cold at the poles. Finally, these are the reference material for our downloading purpose, Energy and the Challenge of Sustainability. These are references books as well as textbooks are available. YouTube animation concept links are available. You can refer for your further understanding. Thank you everyone for your patience listening. Thank you.